students, welcome to another lecture from ecopoint. Today I'm going to talk about a very important concept in linear algebra, and this is the concept of dot product. Why do we need dot product? What will it actually geometrically tell us? So dot product, many of you even know that if you take two vectors, say u, which is u1, u2, so on and so forth till un, which is a vector in Rn, and v, say, which is also a vector in Rn, then we are able to define a product u dot v, which essentially means that you are multiplying these column vectors, but there is a specific formula. What kind of product it is? Well, it's a product which will give you a real value, or it's a product which turns out to be a scalar. So many times it's also called scalar product. So u dot v is defined as u1v1 plus u2v2 plus so on and so forth unvn, which will turn out to be a real number. For example, if I take u, a vector in R4, let's take it as 1, 2, 0, minus 1, the transpose of this, because vectors, as I've already told you, they're generally shown as column vectors. V as 0, 1, 2, 3 transpose. So u dot v would turn out to be 1 into 0 plus 2 into 1 plus 0 into 2 plus minus 1 into 3. And that gives you 2 minus 3, that is minus 1. So we will say that the dot product of these two vectors, or the scalar product of these two vectors, or the inner product. So dot product is also something which is called the inner product, which is a very famous term in linear algebra. What is inner product if somebody asks you? So dot product is an example of inner product. Now this dot product has certain properties which need to be satisfied. And what are they? The very first property, whether you take the dot product u dot v or v dot u, it will give you the same answer, right? So it has to be commutative in that sense. Of course, the way this formula is, it will give you the same scalar out. The dot product of u with itself is always greater than or equal to 0. In fact, u dot u is equal to 0 only under one scenario, if u itself is equal to 0. Something which we can actually call, this is the property of positive definite. You are basically saying positive definite when you take the dot product of u with itself. Well, if you observe, if you think in R2, it is nothing but u1 into u1, that means it's u1 square, plus u2 into u2, so that is u2 square. Of course, these are squares, so it will be greater than or equal to 0. But it will be 0 only when actually u1, u2 are 0. Okay? Number 3, the property, if you take k times u plus L times v and take its dot product with w, it is same as k times u dot w plus L times u v dot w. So basically, L is a scalar, K is a scalar that can come out. Number 4, U dot KV plus LW is equal to K times U dot V plus L times U dot W. Again, K and L come out common. Now, just look at this. You had K times U dot W, so K is coming out. So, if in case you have K times W also, then K square will come out. That's something for you to, think deep. Consider U dot U. If I think in terms of R2, then U dot U, as I mentioned, is nothing but U1 square plus U2 square. I have in the previous lecture done something called the length of a vector, norm of a vector with you guys, right? So can you see that this is nothing but the square of norm of a vector, the vector U, okay? So U dot U is the square of the norm. Associated to the concept of inner product, there's extremely important property in linear algebra that is called the Cauchy Schwarz Inequality. Now, what is inequality is basically telling us is that the absolute value of the dot product of U and V, this satisfies the inequality, the dot product satisfies the inequality that this is less than or equal to the norm of U multiplied by the norm of V. So it is basically less than or equal to the product of the length of U and V. With Cauchy-Schwarz inequality comes a very important consequence of this, and that's the triangular inequality. So if you have any two vectors for UV belonging to, say, Rn, any two vectors, we have that the length of U plus V, norm of U plus V, is always less than or equal to the norm of U plus the norm of V. This will always be satisfied, which geometrically you can see that in case U is this vector, and say this is U, V is this vector. So the sum of U and V would be this U plus V. So one side of a triangle is always less than or equal to the sum of the other two sides. Geometrically, this is what it is. That's why it's called triangle inequality. And mathematically, when we have to prove it algebraically, it's a consequence of Cauchy-Schwarz inequality. So what does dot product geometrically actually gives you? If you say have two vectors, say U and V, now dot product will let you define the angle between U and V. So the included angle, there will definitely be an included angle, right? Because they have magnitude and direction. So the included angle between two vectors U and V is the angle theta between the vectors. Such that theta is between 0 and pi. Now, dot product lets you find this theta. So, how? U dot V is actually equal to the norm of U into the norm of V into cos theta. And with this, you are able to actually find out theta. How? So in other words, basically, u dot v, the dot product, is the product of the magnitude or length of the two vectors multiplied by cos of the included angle. And this, in case you have questions like, say, u is equal to 2, 2, and v is equal to 0, 3. And suppose you have been asked to find out the included angle. Find the included angle, theta. So how do you go about it? Well, you compute u dot v. U dot v is 2 into 0 plus 2 into 3. So it is 6. Then what do? You find norm of u, which is square root of 4 plus 4, that is square root of 8. What else you find? You find you need norm of v, that will be square root of 9. So that will be 3. Now, what we know is that u dot v is equal to norm of u, norm of v, cos theta. So, with this, we know that cos theta is equal to u dot v upon norm of u, norm of v. So, that is, we have the dot product as 6 upon square root of 8 into 3, that is 2 by root 8. Root 8 is 4 into 2. So 2 upon 2 root 2, that is 1 upon root 2. And with 1 upon root 2, can you guess what theta will be? Theta is pi by 4, because its cos pi by 4 is actually equal to 1 upon root 2. So theta has to be pi by 4, okay? And that's how you can understand the concept of dot product or inner product. And that's how you can keep this concept of dot product or inner product, or even called scalar product, in your mind. It helps you define the angle between. That's the entire concept. I hope this will really help you out. Thank you very much.